Hi, well, I'm going to give the presentation on PPI's Building and Construction Division update with a focus on our polypropylene pressure pipe steering committee. Glad to be part of this McElroy Infusion event this year, and I hope everybody enjoys this presentation, and I look forward to some Q&A at the end. So, quick introduction in terms of who I am. My name is Lance MacNevin. I'm the Director of Engineering for PPI's Building and Construction Division. Started with PPI in 2015. I'm a mechanical engineer. I've been active in the piping industry since 1993. And in one of my roles at PPI is I participate in a lot of different technical committees within organizations as shown on the screen here with this alphabet soup of acronyms, everything from ASHRAE to ASTM, ASPE, AWWA, CSA, etc. This is where a lot of the activity happens for codes and standards and advocacy, and it's something that we do a lot of at PPI. My direct contact information is shown at the bottom of the slide here, and you will see this again on the very last slide of the presentation. So I'm looking forward to speaking with you here today. So first of all, we'll describe who is the Plastics Pipe Institute. I'm sure most of you have heard of the PPI before. PPI was formed way back in 1950, 70 years ago, to develop test methods for plastic pressure pipes. And today we're a nonprofit trade association based in Irving, Texas. Our mission is to advance the acceptance and use of plastic pipe systems through research, education, technical expertise, and advocacy. And we do this as a collective with our members, and our members share a common interest in achieving this mission. Today, we're fortunate that we have over 170 member firms involved with the plastic pipe industry, and some of these members are international firms from overseas as well. PPI has 5 divisions that focus on plastic pipe solutions for different applications. I'm involved with the Building and Construction Division, but we also have a Drainage Division, Energy Piping Systems, Municipal and Industrial, and a Power and Communications Division. But today I'm going to be focusing on Building and Construction Division activities, or as we often call it, BCD. So BCD represents 6 major material types, all used in the same space, more or less. And these materials include CPVC, HDPE, which many of you are very familiar with. We focus on the geothermal applications within this division. The material PEX, PERT, PEX aluminum PEX, and of course polypropylene, PPR and PP-RCT, which will be our focus today. So some of these competing materials can be used for the same applications, of course, but there is some overlap. But overall, our members and our committees work together to treat all these materials fairly and to try to execute the mission for all these materials at the same time. This is kind of a family picture here with a collection of different piping materials and smaller sizes from 1/2 inch up to 2 inch. Of course, some of these materials come in much larger sizes. And then we also have a family picture of the different types of fitting systems that are used, whether it be solvent cement fittings for CPVC, or crimp fittings for PEX, or fusion fittings for polypropylene. That's kind of a family picture there. If you go to our homepage, and we invite you to, from the PPI homepage, go to the Building and Construction Division, and that will look like this. And then you'll see our homepage contains a link to each of the piping materials' own webpage. So follow the arrow as shown here and click on the material. And if you click on the webpage for polypropylene pressure piping systems, this will pop up. There's a lot more to it compared to what's shown here. We're really kind of cropping off the bottom. There's even at the bottom of this page, even links to the active product standards if you want to learn more about ASTM or CSA standards. You can get access to them from this webpage as well. BCD focuses on lots of different applications in the plumbing and mechanical space. So that includes everything from plumbing, water service pipes, fire protection, hydronic heating and cooling, which includes radiant heating and cooling, outdoor snow and ice melt systems, chilled water piping systems, district heating and cooling, and ground source geothermal piping systems. And our members are varied. We have the pleasure of representing 66 member firms at this point in time, and they're all exposed on the PPI website. So this is really just a couple of screenshots of our list of members within BCD. So we're grateful for them all, and we appreciate their activity and their support. In terms of our activities, we do a lot of different things, but some of the highlight things that we'll talk about today is our involvement with other industry groups. So one of our jobs is to represent our members' interests in various code and standards bodies. as well as other allied organizations. So here's another big group of acronyms, as you see on the page. You probably recognize some or most of them. PPI is directly involved with these groups through technical committees, other types of committees, participating at their events, and trying to always stick up for plastic pipe to make sure that our materials are well represented and recognized. So here's the official presentation outline. Here are the main parts of what we're going to be talking about today. We're going to start by describing PPR and PP-RCT pipe and fitting materials in terms of their material properties, their capabilities, joining systems, standards, and code compliance. And then we're going to introduce the advantages of these materials over traditional materials, give a quick introduction to the typical applications, and talk about some market opportunities. And then finally, we'll be happy to talk about our Building and Construction Division's Polypropylene Pressure Pipe Steering Committee and how this committee is working together to facilitate the growth and development of the polypropylene market in North America, which is really still kind of in its early days compared to some of the other plastic piping materials in North America. So for the first of these, we'll then introduce the pipe and fitting materials. Some of you probably know this information, but for those who don't, it's probably a good starting point. So PP, we call it PP for polypropylene pressure pipes. PP piping systems are high temperature polyolefin pressure piping systems. So in the same family of materials as high density polyethylene. They were first used in the 1970s in Europe for hydronic heating, and then in the 1990s for plumbing applications. And then these materials were introduced to North America in the early 2000s, which is almost 20 years ago now. There are two types or grades of PP material available today around the world for pressure pipes, and these are known as PPR, or polypropylene random copolymer, and PP-RCT, or polypropylene with raised crystallinity and temperature resistance. Now, both these materials are rated for continuous operation up to 180 degrees, which is very important for code compliance in North America for both plumbing and mechanical applications. And these pipes are available with various pressure ratings because it really depends on the wall thickness or the wall type that is specified. If you need very high pressure resistance, you need to specify a thick wall or a low numerical DR. If you don't need much pressure capability, then you can specify a thinner wall type or a higher numerical DR. And these pipes are used for many of the same applications that our other BCD piping materials are used for. Hot and cold water plumbing, hydronics, chilled water piping, but also some industrial and food grade piping and other applications that we don't not necessarily focus on within PPI until our members ask us to. Just a bit of a comment on dimension ratio. I'm sure most of you know what dimension ratio or standard dimension ratio refers to, but for those who don't, this is a ratio of the outside diameter to wall thickness, calculated by dividing the outside diameter of the tubing or pipe by the minimum wall thickness. The official formal definition for this is found within ASTM F412. But for example, how it works is PEX tubing, which you're probably all familiar with in North America. All the PEX tubing is SDR9, which means the wall thickness is 1/9 of the of the average outside diameter. For polypropylene pipe, it's available in SDR6, 7.4, 9, 11, 17, and 17.6. So a wide range of wall types, a wide range of pressure ratings. But one of the reasons why standard dimension ratios are so important is so that each diameter of a pipe type will actually have the same pressure capability and rating. So in other words, a 32 millimeter and a 50 millimeter SDR11 pipe will have the same pressure rating, even though the 50 millimeter pipe has a thicker wall. In terms of configurations, polypropylene, typically it's provided in straight lengths, and that can vary depending on customer needs. And it's available primarily in metric diameters. There are some iron pipe sizes available according to the ASTM standard, but most of the business is done in metric diameters, which means it's the same pipe being sold around the world. I think it's probably an advantage there. The fittings are molded, some very large molded fittings, but the largest fittings are probably going to be fabricated, which means that they're welded together from cuts of pipes to match the pipe diameters. And within the pipe material itself, there are solid wall pipes, and they can be used if longitudinal thermal expansion and contraction is not much of a concern. But if you do expect a wide range of temperatures, then most people will select a fiber core pipe, which greatly reduces the amount of longitudinal thermal expansion and contraction. In terms of pressure capabilities, these materials follow ISO methodology for long-term pressure ratings, and many people in North America aren't as familiar to the ISO methodology for pressure ratings. A great way to get introduced to that is to look for on our website to the document PPI Technical Note 28, which is shown there. But in terms of specifically what the polypropylene materials are required to have in terms of minimum tensile strength, these requirements right here are pulled directly from the latest CSA standard, B137.11 for polypropylene materials. So PPR compounds need to have a minimum tensile strength at yield of 21 MPa at 23 degrees C or room temperature, and PP-RCT compounds have a minimum tensile strength of 25 MPa. And then these compounds also have what's known as minimum required strength and categorized required strength requirements. And again, I'm extracting the information here from the latest version of CSA B137.11. And I don't need to read all this to you because it's not exciting to read or to listen to, but this is specifically what it says in the latest version of the product standard for the MRS and the CRS values for both PPR and PP-RCT. So that's a lot of information on the material itself and its capabilities. In terms of how it's joined to make a piping system on the job site, we'll talk a little bit about fittings and joining and how you will actually build up that system. And we're grateful to lots of great photographs here from McElroy and Aquatherm and others showing materials in use and fittings in use and some job site pictures. So there's three main methodologies by which these pipes and fittings can be joined: heat fusion, which is the most common, electrofusion, and also grooved mechanical fittings. So heat fusion, you're probably familiar with that if you're at McElroy Infusion. Heat fusion joints are welded under pressure to form continuous piping systems. So very similar as you would be welding HDPE pipes together. The process is very similar for polypropylene pipes as well, although the exact pieces of equipment may be a little bit different. So here's some great images here showing a close-up of a fused pipe joint on the right-hand side, courtesy of McElroy. Thanks again for these pictures. And as you know, when you do a fused joint and it's done correctly, which it should be, then you end up with essentially a continuous piping material. Here's another great photograph here of pipes and fittings being fabricated on the job site, but on a work table as opposed to working overhead. So doing a lot of prefabrication work on a table can certainly save a lot of time and reduce the need for a lot of overhead equipment. And here's another great photograph here of building a long pipe that's going to be a buried pipeline, ultimately. Second technique for joining polypropylene pipes is the process of electrofusion. So similar to electrofusion fittings for PE piping systems, there also exist electrofusion fittings for polypropylene piping systems. So it's the same concept, which means you've got embedded copper wires inside the fitting. And when you prepare your joints, meaning cleaning the pipe, cleaning the fitting, inserting the pipe into the fitting, then you connect the electrodes on the fitting to a computerized fusion device, which controls the heating process for the right amount of time until you get a good fused joint between pipe and fitting. And then there's also grooved mechanical fittings. So a good thing with groove fittings is you don't need electricity on site. You do have to be able to groove the pipes and groove the fittings to be able to prepare them to be joined with the couplings, but otherwise there is no heat fusion involved with grooved mechanical fittings, so that's also an option. With regards to product standards, it's important for everybody to know that this industry is highly regulated and highly standardized. Within ASTM, the standard is kept up to date by industry. The latest version is ASTM F2389-19. So that means the standard was just updated last year. And it covers nominal sizes from 16 to 355 millimeter, as well as some IPS sizes and Schedule 80 wall type. The CSA standard I mentioned before is called CSA B137.11, and the latest edition of that is from earlier this year, published in 2020. And it covers nominal sizes from 3/8 to 28 inch, but it's not different pipes. Those pipes actually have the exact same metric dimensions in terms of outside diameter and wall thickness as you find in ASTM F2389. So the dimensions are harmonized within the two different standards. And within our polypropylene pressure pipe steering committee, our members and PPI staff work hard together to work on these standards, to always be updating them and to keeping them as harmonized as possible, even though they're in slightly different cycles for getting updated. And we'll talk more about that later when we look at some of the projects we're working on these days. But the good thing about these standards is they specify a lot of specific information. They specify the material strength that we looked at before, and I gave some excerpts on that. Topics such as workmanship, dimensions and tolerances, quick burst pressures. They specify how to derive your long-term or sustained pressure ratings, how to ensure that the products have thermal stability and oxidative stability, such as chlorine resistance, thermal cycling resistance, which is a good test of the joints, the connections, is embedded in the standards. Obviously, the test methods, even the marking requirements, are all part of these standards. So if you really want to learn more about the specific requirements of a type of pipe, just get access to these ASTM or CSA material standards and you will learn a lot. With regards to code compliance, actually quite a while ago, members within the industry worked to get these product standards published first and then to get those standards referenced within plumbing and mechanical codes across North America. So on the plumbing side, polypropylene pipes and fittings are listed today within our model codes, such as the International Plumbing Code, the Uniform Plumbing Code, the National Standard Plumbing Code, and the Canadian National Plumbing Code. As an example, from the latest version of the International Plumbing Code from 2018, if you looked at Chapter 6, Table 605.4 is the list of approved water distribution pipe materials, and you'll see polypropylene is listed in that table, and it references the standards ASTM F2389 and CSA B137.11. So as long as the product is shown to comply with those standards, then it meets the requirements of the International Plumbing Code. And on the mechanical side, same story essentially. These materials are referenced within the International Mechanical Code, the Uniform Mechanical Code, and another code known as the Uniform Solar, Hydronics, and Geothermal Code for hydronic piping applications. So as our example for this one, we're going to refer to the latest 2021 edition of the Uniform Mechanical Code. And if you look at Chapter 12, which is about hydronics, Table 1201.1 actually lists the materials that are required or materials that are permitted and allowed for hydronic piping systems. And again, we see polypropylene as long as it complies with ASTM F2389 and CSA B137.11. So that wraps up our first part of the presentation on the pipes and the fitting materials themselves and the joining and the standards and the code compliance. Next, what we want to do is talk about the advantages. Why would people use polypropylene over traditional materials? And then what are the applications that we're trying to open up the markets for and expand the markets for? And then what are some other market opportunities? So it's always nice to be looking towards the future and see where those opportunities are. So that's what we're going to address next here. And in terms of the advantages, I know I'm probably speaking to the choir that most of you are quite familiar with the advantages of plastic piping systems in general. So you know what, it's really a question of how short or how long can I make the list. In this case, our list of advantages could be longer, but there's really only so much room on the page. So here's kind of a generic list that applies to a lot of plastic piping materials, but certainly specifically to polypropylene piping materials. So obviously we've got safety of potable water and long-term reliability. I mean, the main job of a pipe is to be a good pipe, which means keep the water inside and don't let the water out. And obviously to be nice to the water and to be safe to the water. So that's kind of addressed right up front here. One of the ways that you ensure long-term reliability, though, is to make sure that you are resistant to corrosion and you don't allow mineral buildup. Well, plastic pipes certainly satisfy that. In plumbing applications, you also have to be resistant to disinfectants, such as chlorine and chloramines, and that's a requirement in the polypropylene standards that the pipes must be tested in accordance with ASTM F2023, which is a test method originally developed for PEX tubing systems to demonstrate their chlorine resistance. Now it's also required to do that testing for polypropylene piping systems. Another advantage of these materials is you've got heat fused or mechanical joints with no flame used for joining, and we'll talk about that more in a few minutes. We've got durability and toughness to survive job site installations. It's not a delicate material. It can survive being banged around a little bit, which is great. We've got chemical resistance, which is important in a lot of hydronic systems that may use glycol or other water treatment chemicals to protect cast iron boilers or other steel pipes in the system. Obviously, ease of installation, and we'll see that through many of the job site photos we're going to see here. And it does deliver a very professional appearance because of its straightness. It's lightweight, easy to transport, and in today's day, actually, if you could have fewer workers moving a piece of pipe around on the job site and allowing our so-called social distance between the workers, that's a bit of an advantage. So lightweight actually has a practical advantage, especially today, I would say. It's faster to install, which it's also going to be safer for workers because of its lighter weight, easier to manhandle and maneuver around on the job site, and probably fewer injuries as compared to heavy steel pipes. The material itself is a natural insulator, which means we have lower thermal conductivity. We don't skip insulating just because of this. We would also insulate these pipes just like you would insulate metal pipes, but the good thing is you get some extra insulation built in to the pipe wall itself and the fitting wall itself. The good news is, in addition to all these practical advantages, it's also going to be a lower installed cost than metal pipes because of significant time savings when building a piping system on the job site. And then finally, it's really an advantage to a lot of the contractors, the fact that polypropylene piping materials are really not going to have any scrap value, unlike copper or some steel piping systems. And that really helps to avoid a lot of job site theft, where materials disappear overnight from job sites. That little image, if you can make it out, that's a typical piece of used steel pipe with some corrosion and some buildup going on inside, which that exists in probably much of the steel pipe in existence today, whether it be a plumbing system or a hydronic system. If you could see inside, you would probably see layers like that inside those piping systems. You will not see that inside plastic piping systems. On the sustainability and safety side, I think this is an important thing for us to remember. If you pay attention to this space, plastics as a material are under attack all the time from people that just want to eliminate maybe anything synthetic or man-made from our environment. But really, as a bit of an environmentalist myself, I really believe in plastic piping materials, and there's lots of good reasons for that. I truly believe that they're better for the environment than traditional materials. So here's a bit of a list in terms of why that is the case. First of all, we're not doing any mining operations to get to the ore. Unlike copper or iron, the raw materials, the base materials used to make our plastic piping systems are pretty much coming from natural gas or crude oil. The part that's not used for energy, for gasoline or jet fuel or lubricants or something like that, through the magic of chemistry, gets converted into useful plastic materials. But there's really a very low energy cost and low environmental cost to produce those materials in the first place, especially as compared with traditional piping materials. So that means we've got a lower environmental footprint and lower embodied energy for production, dramatically lower as compared to metal piping materials. The pipes themselves have a smooth wall and excellent flow characteristics over time. That doesn't change. It's not going to build up with material deposits inside over time, which will require bigger pumps and bigger pumping energy. It's going to stay very consistent. The flexibility of the materials can actually dampen water hammer, and that helps to reduce pressure spikes, which is good for all the other equipment connected to the pipes in a piping system. The materials don't add minerals to drinking water, and they don't support biofilm growth, which is important in both the hydronic and the plumbing side. These materials, as you've heard, have proven long life and the durability, and that's going to provide value and reliability over decades of use. Again, the lightweight that we talked about before is reducing transportation volume and costs. And ultimately, these plastic piping systems are protecting the health, safety, and welfare of our building occupants. Oh, and by the way, polypropylene pipe and fittings are recyclable for your leftover pipes at the end of a job site. Now, one of the other big sustainability and safety issues, I think, a big advantage here, is the elimination of open flame for joining because of fusion joints. If you're welding steel or brazing or fusing copper, even using propane torches for copper in a typical plumbing job, there's always the risk of something catching fire. And in a lot of buildings, you actually are required to have hot work permits to make sure that there's going to be certain types of protection set up and overseeing and people standing by with fire extinguishers just in case something does catch fire. It is unfortunate that a lot of existing buildings, whether it be new construction or renovation work, do end up burning down because of a welder's torch or a plumber's torch. And in terms of what hot work means, here's our definition from OSHA. That hot work means any work that involves burning, welding, cutting, brazing, soldering, grinding, using fire or spark producing tools, or other work that produces a source of ignition. Heat fusion tools don't fall into that category. So that means we can avoid hot work permits. That's a big advantage to installers. All right, let's move on to applications. And this is going to be fairly brief because a lot of this is fairly obvious, but we're just going to give a couple of examples of applications in plumbing distribution, hydronic heating and cooling, and chilled water. Of course, there's other applications in food processing, industrial and chemical transport, and even geothermal headers and manifolds, but we're going to focus on these top three right now in today's presentation. On the hot and cold water plumbing distribution side, polypropylene, it's often used in commercial plumbing applications. So we're talking about the risers going vertically in pipe chases. We're talking about headers going down hallways or inside ceilings of buildings. And if you're dealing with something like an apartment building or condos or hotel, they'll often use polypropylene for the larger pipes. And then sometimes they even switch to the flexible piping materials like PEX or PERT for their smaller drops into individual apartments or condos, I think. But the benefits of using polypropylene for this application, again, fairly obvious to most of us on the web here today, but just as a bit of a reminder, here are some of the same benefits that we looked at before: safety of the water, corrosion resistance, resistance to our disinfectants. We've got heat fused or mechanical joints without the flame. The pipes themselves deliver durability and toughness. We've got the ease of installation, lower thermal conductivity. With regards to the lightweight, there are reports that it's up to 70% less than metal pipe, to quantify that a little bit. And again, lower installed cost. Who would not like that? On the hydronic heating and cooling side of things, I'm a big fan of hydronics, by the way, as compared to using refrigerant to distribute heating and cooling energy through a building. And it turns out that water, which actually has an R number of R718, it's really the optimal heat transfer fluid for heating and cooling systems. So PPI does spend some time promoting hydronics over VRF systems. And in terms of overall system efficiency, hydronic systems deliver 30 to 40% energy savings due to lower pumping costs. So basic pipes with water and circulating pumps are far more efficient than using refrigerant systems with copper tubing distributed through a building and having those compressors distributing our refrigerant over hundreds and hundreds of feet throughout buildings, whether that be a school or a hospital or an apartment building. Hydronics is always going to be more efficient, and plastic piping is the way to go for distributing our hydronic energy. So again, the benefits: reliability, the benefits of our heat fused joints, durability and toughness, resistance to biological growth and the organisms that can form inside metal pipes. We're resistant to that. Lower thermal conductivity is a big advantage here. The lightweight, again, fewer workers on the job site, and lower installed cost. What's not to like? And then chilled water is just really an offshoot of hydronics, but chilled water is kind of a special type of application. And polypropylene, again, is kind of an ideal piping system for most chilled water distribution applications. The temperature and pressure ratings are a good match for most of them. And again, the benefits are very similar to the benefits for other hydronic systems. In terms of opportunities, so we've talked about lots of opportunities already in new construction. And new construction does cycle up and down a little bit. But if you think of the existing buildings out there, there's a lot of existing buildings out there that are old. And at some point, probably not too long from now, are going to need to be repiped, with their old plumbing pipe replaced, as well as their hydronic pipe replaced, because there are a lot of existing old commercial buildings with hydronic systems. And we want to keep those hydronic systems alive so we can replace old pipes with new pipes. To quantify that a little bit, you can do some web research. And the Commercial Buildings Energy Consumption Survey, which is one of these sources of information, estimates that there are 5.6 million commercial buildings in the US. That was back in 2012. And that adds up to 87 billion square feet of floor space. So that's a lot more buildings than what's going to be constructed in the next year or two. Only 12% of these buildings were constructed since 2003. So that means there's a lot of old buildings out there. Approximately half of them were built before 1980, which is, do the math, that's 40 years ago now. So another estimate reports that in 2017, the average age of buildings was practically 50 years old. A lot of these piping systems have a 50-year piping life expectancy. So that means that there's a lot of opportunity out there. So when we talk about old buildings that need new piping, we're not necessarily talking about old stone buildings from the turn of the last century. Really what we're talking about here could be buildings from the 1970s. 1970 was 50 years ago, and there's a lot of 50-year-old buildings out there and older buildings out there that are probably going to need new piping systems soon. So when these buildings do need to be new piped, just look at these cityscape photographs here and you can see how many buildings are out there, and just imagine how much pipe is inside those buildings. And whether it's steel or copper, just imagine how those pipes are looking inside right now, whether it's plumbing or hydronics. It seems to me there's going to be a lot of buildings needing some new piping before too long. So again, our advantages of polypropylene for these buildings, which is really ideal for all this replacement work. We've got ease of prefabrication offsite. If you know the dimensions of the pipes and the lengths and how often you need your fittings and things like that, you can fabricate a lot of that offsite and bring it to site. The prefabricated segments are going to be easier to maneuver through the buildings with less equipment. If you're doing a lot of steel pipe in a building, it's very heavy and you're probably going to need lifts and lots of mechanical, hydraulic chain support and everything else to move those pipes around, whereas lighter weight materials can really make that a lot easier and safer to move the piping through existing buildings. And again, joining without flame is a huge advantage in existing buildings because it's always best to not burn down the building that is being rebuilt. And this unfortunately does happen with, like I said before, a welder's torch or a plumber's torch, but we can pretty much eliminate that risk by eliminating the flame used in heat fusion. So to me, that's a huge advantage and a huge opportunity of our piping materials. So the final part of the presentation is to talk about how our P4 steering committee is facilitating the growth and development of this market into North America. So a little bit of background, first of all, it was at the end of the year 2017 that PPI decided to form our polypropylene pressure pipe steering committee. We had 2 members that made this type of piping material at that point, but we weren't really doing a lot of activity directly for them, just for the polypropylene. So we formed this committee at the end of 2017. We had a kickoff meeting at an ASHRAE show, AHR Expo, at the beginning of 2018, where we invited old members and people who weren't members to come together and talk about forming a committee like this. And most of these people agreed that, yes, this is a good idea, we should do this. So we had our kickoff meetings in early 2018 with a larger group of manufacturers. And then once we knew that this was something we should be doing within PPI, we issued a press release in June 2018 to announce the formation of what we called our Polypropylene Pressure Pipe Steering Committee and let people know that this committee was in business and the type of work that we'd be doing. The press release actually got some great exposure. Just bringing up some clips here of some of the media outlets that published our press release on our behalf, and we were very grateful of that to let the world know. And that actually allowed us to gain new members as well. So this committee has grown within PPI since that date. Coming up on the screen now are the logos for all the member firms that are active in our polypropylene pressure pipe steering committee. These are the firms that are actually producing pipes and fittings and valves of polypropylene material. And we have a lot of other members as well. As shown in this list here, listed alphabetically, These are other firms that maybe are producing the materials used to make these pipes and fittings, or the equipment for joining, like McElroy, or test labs and certifiers that are involved with this space. So we really appreciate all of their involvement, their ideas, their suggestions, and their contributions. The committee obviously is nothing without the participation of all these people. If you're not a member of PPI and you'd like to get involved, again, I'll show you my contact information at the end, and we invite you to give me a call and ask about how to get involved with this committee. In terms of the structure of the committee, I'll give you a bit of an overview here of our organization and our structure and our activities. We're fortunate that we have Jim Pascal, who we sometimes call Professor Jim, as the chairman of our committee since its inception at the end of 2017. And once the committee got underway, we realized it's a good idea to also have a vice chair. So Christian Harold of Teal Plastics, who is also the vice chair of the Building and Construction Division of PPI, he has volunteered to be our vice chair ever since, so we thank them both for their time and their commitment to this committee. And what does the committee do? Well, we do quarterly conference calls. We just had one recently where we hear input from all our members in terms of what does PPI need to be doing or what do our members need to be aware of to help this market grow in a responsible way. We typically try to get together at least once a year in person at AHR Expo events. So we were together last February in Orlando for a 1.5 hour meeting. We started a quarterly statistics program on shipments within North America that includes several participating manufacturers. So they submit the data to an accounting firm, and then they get the total figures back from that accounting firm through PPI. We participate in some training and education. PPI does a lot of education, and we always represent polypropylene materials within our educational courses and presentations. We do some advocacy activities. So advocacy can mean a lot of different things, but one of the things it means is promotion through magazine articles, technical articles. This article here just published last week on facilities.net, and PPI didn't write the article. In fact, the author of the article interviewed myself at PPI, plus 6 or 7 other PPI members and other piping producers to write a really interesting story about plastic piping systems overall. But that's one part of advocacy. And then back to our overview here in terms of what we do, we also do a lot of R&D work, which to me that means technical projects, research and development projects. So here's a huge list of projects. They all get a number based on when the project started and sequentially what project was it that was started during that year. So our oldest of these goes back to 2016, and it's complete, addressing flow-induced copper corrosion. And then the second oldest is one that had to do with revising CSAB 137.11, also complete. So for the oldest of these projects, which started in 2016, to address flow-induced copper corrosion, Jim Pascal chaired the project, and with a committee of task group volunteers, we ended up publishing this document known as TN57 in June 2018, which addresses what can happen if you have excessive velocity through mixed material piping systems, where you can actually start to dissolve copper ions from the copper pipe, and those dissolved copper ions in the right conditions with the right water chemistry and everything else can be aggressive to polypropylene materials. So please read TN57 to learn more about what I'm discussing here. The rest of these materials, or sorry, the rest of these projects showing up in black are projects that are still actively underway. Some of them are close to being finished, some of them are just beginning. But for instance, the top one on the list in black is called BC 2016-02, otherwise known as version 2.0 of the BCD calculator. So the BCD calculator has been published on the BCD website since the year 2015. And it was originally built to allow people to do some online calculations for the piping materials that BCD was focused on back then, which is PEX, PERT, and CPVC. And the calculator does pressure and head loss calculations, hydraulic shock calculations, pipe weight and volume calculations, thermal expansion, and even helps users design expansion arms and expansion loops. So the big goal of version 2.0 is to add in our new materials like our polypropylene materials into this calculator. The work is almost done. As you see your screen change, this is the view of the new calculator. We're changing the appearance as well as adding in the new materials and many other sizes of existing materials And pretty soon, the update to this calculator is going to be going out to ballot within our division of PPI, and that will approve the changes that we've made. And it should be able to be going live before the end of this year, 2020. So Gary Morgan of Borealis has been the chair of this project since the beginning, and we thank him for his time and dedication on leading us through this one. The rest of these projects, as you can see, it's all things that the industry needs. And it couldn't be done without all the input and ideas and suggestions and words and text and writing of our task group and steering committee members. So we have everyone, again, from Jim Pascal chairing several of these projects, Steve Sandstrom of Borealis, Scott Milburn of Aquatherm, Jim Pascal again, Joe Ponatowski of Asahi, Max Cummings of Teal, and even myself once in a while end up chairing one of these projects when it's obvious what the result is going to be. So it's a lot of work going on. We don't do all of these at the same time, but typically at least 5 of these projects are moving at the same time. And we have a lot of task group calls, including all the companies that you saw on the slide a few minutes ago are actively involved with these projects. And again, we thank them for their time. And then finally, I need to point out that none of this would be possible without the overall PPI team. And what do we mean by the PPI team? Well, that includes a total staff of 11 people at PPI, as you can see on this contact page here from our website. Our board of directors, we've got 5 management committees for the 5 divisions. We have several overall PPI committees, such as the safety committee, education, technical, and sustainability committees. Several of those are led by either Patrick Vivian or David Fink. We've got many division committees, and the polypropylene pressure pipe steering committee is known as a division committee. And then within PPI, we have dozens of project-focused task groups, several of which you just saw on the previous slide. So really, the story of PPI is members identifying needs and working together for the good of the industry. And we're grateful to be able to serve them and to help execute what they feel the market needs. So that brings us to the end of our presentation. We achieved all 3 of these items in terms of discussing the materials, advantages, applications, opportunities, and then discussing the work of our polypropylene pressure pipe steering committee. So with that, we'll bring it right to the end. I thank everybody for your time. I appreciate you paying attention today.
Okay, Lance, we are live.
Hi, Chris.
To our guests, welcome to the Q&A section of the PPI BCD update. Lance, well done, as always. Thank you so much for your participation. As I was watching your presentation, I was reminded again that you are just a walking, talking wealth of plastic pipe knowledge and information, you know. And I thought of one thing. I thought, I am certainly glad that you're on our team, you know, that you're working with the plastic pipe guys, not one of the alternative piping materials.
Well,
but
you know what, being on part of this team, it's hard not to learn new information every day. Products are evolving, applications are being tried out for the first time. New equipment is being developed all the time. So this is a really dynamic industry, and it's a great place for older people that have a lot of knowledge to be able to share it, but it's also a great place for young people to keep bringing new ideas as well. So
yeah, you know, I agree. It was 29 years ago when I came to work for McElroy, and I've had that exact same thought every single day. I've had the good fortune to come to work. It's just, what a great place to be. What a great industry to work in. I was thinking about, you know, where we're at with the division, building and construction division, and the steering committee, the P4 steering committee. And I took myself back in time a little bit, and it was at Infusion. I don't know the year, but several years ago, I can remember a couple of years specifically chairing breakout sessions for polypropylene groups, and some of the primary conversations centered around how do we get organized as an industry? How do we move forward with a unified voice? How do we come together in much the same way that the polyethylene industry did many years ago, And so it was such a pleasure to see in 2017 this division come to be.
Yeah, so funny you mentioned that because it was exactly, I think, after the last minute of Infusion 2017, I happened to be up in Anchorage at an IATMO plumbing conference, and I started getting phone calls from PPI members who were just walking out of your conference saying, "We need to do something for polypropylene. How do we start focusing on this within PPI?" And we put it together as quick as we could, as you heard, and we kicked this off in December 2017, the steering committee.
And you know, the rest is history. I think we've got a lot on our table as a group, but we've made tremendous progress, and you spoke to much of it. Let's get started with some questions here. We've got about 15 minutes, maybe not quite that, but just as they sort of rise to the top. Lance, what is the primary difference between PPR and PP-RCT? And are those two compatible, complementary? Give us your thoughts.
Yeah, sure. Well, I'm not the chemist, so I'm not going to get into the molecular differences from one or the other, but from the practical aspect, they're both polypropylene pressure pipes, obviously. They're completely compatible with each other. So if somebody had PPR fittings and PP-RCT pipes, they fuse perfectly well together. They can be joined to make a system. The main difference, and I mentioned this in the presentation when I was getting into the weeds a little bit with regards to the pressure ratings, the PP-RCT materials are a bit stronger. They've got a higher tensile strength, and that can lead to a higher pressure rating for the same wall thickness. Similar to how PE4710, it's a stiffer, stronger material than PE3608. It's kind of similar in that sense, that the PP-RCT has a higher pressure rating for the same wall thickness.
But are the two compatible?
Yeah, they're completely compatible. If you were building a system using both components, obviously the pressure rating of the system would be based on the lowest pressure rated product within that system. But yeah, if you've got PPR fittings and PP-RCT pipe, you can easily build a system with both. They fuse in the same way. The fusion procedures are the same for both.
Gotcha. Next up, just going from our submitted questions here, can you talk about the flame and smoke ratings for PPR and how that relates to the use in a return air plenum?
So these are polyolefin materials, which is a chemist's word for the family of materials. It also includes HDPE and PEX, which means that they do burn very slowly like candles. So they don't burst into flames, but they will burn and they will give off smoke if they catch fire. So in commercial buildings, it's common that the empty space above a drop ceiling in the building is the return air plenum. That's where the return air for the HVAC system gets sucked back to the HVAC system. So the building codes require that any materials put up inside your return air plenum have to meet certain flame and smoke spread ratings. There's a couple of different methods for testing that, but essentially when they do that test, they take a piece of pipe at a laboratory, 20 foot long, apply flame to one end of the pipe, and they measure how quickly does the flame work its way down the length of the pipe. And also with optical sensors, they measure how much smoke is being developed. Most of these polyolefin pipe materials do not meet flame and smoke spread requirements as naked pipes, empty pipes on their own. But that's okay, because for the most part, these pipes are used for hot and cold water. And it's required for hot and cold water that you're going to have to insulate the pipes to keep the heat in or the heat out. So that's a requirement for energy codes and for all practical reasons. So the type of fiberglass wrap insulation that people are using for keeping the heat out or keeping the heat in is typically also a perfect fire barrier because the fiberglass insulation doesn't burn. So basically what has to happen, sorry for the long answer, but basically what has to happen is that each pipe manufacturer has to get their pipe tested as it would be installed with that fiberglass wrap insulation at a test facility such as UL to prove that the use of that insulation protects their pipe from the flame and protects it from catching fire and from developing smoke.
Gotcha.
So the short answer is there's no universal flame and smoke spread listing for all pipes. Each manufacturer has to do that testing on their own and has to provide that listing, that certification to the users to prove that their pipe, when installed correctly, will meet those requirements.
Gotcha. Next question. Let's talk fusion. Okay, we're in my world now. What fusion procedure should be used to join PPR, and is it basically the same as for HDPE?
It's similar because we saw a lot of great demos today with your team showing the type of equipment that's being used. So the process, essentially, it's very, very similar, although the exact heating temperatures and times and pressures are going to be a bit different. In North America, each of the manufacturers has done a great job of publishing their own procedures, as McElroy has done as a major equipment provider. In Europe, they actually have a European standard on polypropylene pressure pipes, and the fusion procedures, for the most part, are coming from that European standard called DVS2207. So I think right now, all the companies selling these pipes into North America are basically reusing the DVS2207 procedures for fusion and putting that in their literature. The good thing is within PPI, we actually have a committee working right now, and you're part of that, that's developing an ASTM standard practice for heat fusion. Right. So when that gets published, hopefully about a year from now, that'll be finished and will be published. It'll be similar to ASTM F2620 for HDPE fusion. And when that gets published, then that will be the industry standard procedure.
Right. So in answer to the question, briefly, there's just the process is essentially the same. The parameters of fusion are a little bit different, and typically the demands of the site are or can be different than some of what we see in HDPE. So
sure,
a little bit some unique equipment designs there. Let's take that same joining question a step further. Let's talk about joining the PPR pipes to the metallic pipe, steel or copper. What are the considerations there?
Right, and that's done every day because a lot of building systems out there, they might have a metal manifold, and then they're using polypropylene pipe to branch off from that, or they've got copper in a plumbing mechanical room, making headers or connections to water heaters, and then going to polypropylene from there. So this is done all the time. For the smaller diameter pipe connections, like 4-inch and smaller, it's common to use threaded fittings. So as you may have seen in some of the demos earlier today, you can terminate your copper maybe with a male pipe thread fitting, and then from there you begin your polypropylene with a female pipe thread fitting that gets fused onto your polypropylene, and you go from there. For the larger diameter pipes, it's common to use flanged connections. So if you've got some 12-inch steel pipe as hydronic piping in a big building, and you want to repipe that or extend that with polypropylene, that's typically done with a bolt-up flange connection.
Great. I'm going to deviate from the submitted questions here. I'm going to ask one of my own. You spoke of the many advantages of PPR and plastic pipe, of course, and the applications and opportunities. You went through that whole sort of scenario and outlined, the examples of the age of a lot of our building infrastructure and how these piping systems inside buildings are aging out, and they're just going to require a lot of work. In terms of the adoption curve in general, whether it's new installation or rework, in terms of the adoption curve, where do you see PPR right now?
This
is an opinion I'm looking for.
Yeah, this is just an opinion. I wish I had that crystal ball vision in terms of exactly how many pounds of each type of pipe are sold every day. I think we're really at the bottom, a little bit beyond the bottom. Obviously, polypropylene started in Europe 30 years ago. It takes a while for a lot of new technologies to get from Europe to North America. It's been in use in North America for about 20 years now, but in the beginning, it was one contractor at a time. And in a lot of cases today, it's still one contractor at a time because there's a bit of a learning curve. The contractor has to tool up, get the right equipment. So right now, I think all the polypropylene pipe producers are reaching out. They're gaining one contractor at a time, training them, getting them equipped, making sure they know what they're doing, and then moving on to the next one. So, I think we're still very much in the early days. I think it's going to explode fairly soon. But every type of plastic pipe takes years to get accepted for whatever reason, whether it's underground or in building. It takes a while. So we're probably where polyethylene gas pipe was 40 years ago. We've got no black eyes. The pipe is doing great so far. A lot of people are still sitting back and waiting for the time for them to dive into this market, and hopefully this will be that time.
Right. That's great news. Lance, you mentioned the PPI website, and this INFUSION20 is a global meeting, and we have a global audience with us today. To those guests, perhaps outside of North America or not currently PPI members, what could you tell them about the PPI website, the resources available to them, or perhaps some of the activities that your group has with the international team?
Sure, thanks. Well, first of all, when you go to plasticpipe.org, remember PPI has 5 divisions, so the first thing you have to do is click on the division button to get to building and construction. But right from that BCD homepage, we represent different materials within BCD, so we try to give them all equal exposure. So right from that BCD homepage, if you scroll down just a little bit, you'll find the link for polypropylene. And on each of those material pages, we try to tell the full story of that piping material in terms of how long has it been around, where did it come from, what are the approved applications for that piping material, the advantages of using it, and then we provide live links to the product standards at the bottom of the page, because we talk a lot in standards. So if we're talking about ASTM F2389 and somebody's thinking, what the heck does that mean? Right from that polypropylene material page, you can find the link to that ASTM standard where you can read about it and then buy the full standard if you want to.
Gotcha.
So that's just a little bit of information. We've got some under the education tab. If somebody goes under the education tab and then clicks on the button that says presentations, we've actually got a bunch of PowerPoint presentations on our different materials. And the one in the upper left right now is a big presentation that was actually put together 1 year ago for a US government entity, describing all the plastic pressure pipe materials that we represent. And it provides a lot of information on each of them.
And this information is all free, readily available.
Yeah.
Just visit the site, download it, use it.
Right. This is not for members only. It's publicly accessible. Our web traffic grows every month as we find new ways of promoting ourselves and letting people know we exist.
Right.
In fact, just today, or in the last 24 hours, a press release got published about PPI signing a memorandum of understanding with the American Society of Plumbing Engineers, otherwise known as ASPE. We worked on that for a long time. The MOU was signed a few weeks ago, and the press release just went out yesterday. And that's been published by 6 or 7 media outlets in the last 24 hours. It's kind of big news.
Yeah, I just saw it and liked it on LinkedIn, by the way.
Oh, thank you.
Yeah, right.
So yeah, we're doing lots of outreach with other organizations as well, so that PPI can be part of the design process, the standards process, the code process. So hopefully people that haven't heard of PPI up till now in this world will start to see us being exposed a lot more soon.
Great. Lance, we've got a couple of minutes left. I'm going to throw a question out here that has come up. Can you speak about PPR and UV exposure, both in terms of outdoor installations or outdoor applications, as well as exposure during the construction phase of a building project and those types of things? We've got a couple of minutes.
Okay, well, I'll take the second aspect of that first, because during regular construction, yeah, it's normal that the pipes are going to be exposed to the sun, because we don't always put the building up first before the pipe goes. So polypropylene pipes are all formulated to withstand a certain amount of UV exposure. I think for most of them, 3 to 6 months UV exposure is not a problem. So, but in general, the pipes are going to arrive on the job site with some protective coating, packaging. Installers should keep it protected until they're ready to use the pipe. Don't just leave it sitting out in the pipe field for months at a time with no protection. So in general, the pipes do have some UV exposure against that kind of incidental exposure during construction. But then there are some instances where people are actually installing polypropylene pipes outdoors on the roof of a building, and it's going to be out in the sun all the time. If that's the intended application, they really should speak with their supplier. You can either get a specially formulated polypropylene pipe that has UV inhibitors built in that is meant for that, or if it's going to be an insulated pipe, and it usually is, the insulation that goes over the pipe normally is going to provide the type of UV protection that you need in a permanent outdoor installation. So there's a few different ways of dealing with it. I'd recommend to speak with the manufacturer to make sure you get their best advice.
Gotcha. Great. Well, that's the end of our time. Lance, again, great job. Thank you so much for your participation. I think it's been a great presentation. I took one quote from your one of your slides here that really hit home with me, and that's PPI members work together for the good of the industry, and that's really what it's about. It's about moving this industry forward. And you guys are great at it. We appreciate all your hard work, everything you do. We weren't able to get to all the questions here in the Q&A. I would encourage our guests, if you have questions remaining, reach out to Lance or I directly, or visit the virtual booths or your McElroy salesperson, and we'll be sure and get your questions addressed. So thank you, Lance. Thank you to our audience. Thanks for visiting us at INFUSION20 and for your hard work and efforts. Thanks.
Happy to be part of it. Appreciate the time. Bye-bye.
Bye-bye.